You're right, I do have 100 slides. Let's get started. I am the author of all this content, so any mistakes or opinions in here, please blame me for that. Don't blame anybody else. Before I get started with my content, I want to see if you're really awake after that lunch that you had. So we're going to have a quiz. Everybody ready for this? All right, pay attention. Pay close attention. I have a Unicode string on the screen in front of you. And I would like you to tell me what you think the length of this string is. Your choices are 4, 5, 6, 12, 14, and 20, and we're going to do a vote. So look carefully. If you think the length of this Unicode string is 4, raise your hand now. If you think it's 4, raise your hand. The length of this Unicode string at the top of the slide. All right, 5. Any votes for 5? 5? We got 1 for 5. 6? Anybody think the length is 6? Are you guys awake or not? I can't tell. 12. Do you think the length? All right, we got to vote for 12. You have to vote for something, guys. You can't just vote for nothing. 14. Is it just because voting is a really sore topic right now? Sorry. 20. 20. All right, we got a 20 back there in the back row. Okay, let's find out who is right. Are you ready? You're all correct. Good job. And now you have a sense for how this talk is going to go. That second character in there is actually a combination of 2 Unicode code points. Unicode has these things where you can modify the previous character, so like maybe add an accent to it. In this case, it's adding a vowel sound to it. Another interesting thing about Unicode, so if you're not real familiar with Unicode, you have this thing called a code point, which is basically your primary key, is what it is. It's just kind of, Unicode's like a million different potential characters, and they can be assigned, and the code point sort of tells you which one you are. But then, you have to figure out a way to actually represent that thing as bits and bytes. And one of the things you'll notice, like from this equid ideogram, is that the numbers get quite large. So that right there is not something that you could possibly represent in 16 bits. So there's quite a bit of interesting stuff going on in Unicode. All right. Let me introduce myself now. My name is Jeremy Schneider. I'm really glad that all of you are here because I really needed some database people in the room today. I know next to nothing about databases. I know almost nothing about Postgres, so it's a good thing you showed up. I am a tenured university professor of linguistics, in fact, with a serious thirst for adventure. At this very moment, I am on an airplane on my way to northern Pakistan, where I'm going to be doing some field work and studying the Balti language, all right? Because I want to take some of my machine learning and AI experience and then do that on-the-ground research and find some new insights into the Balti language that nobody's ever found before. So Balti can be written, it's Persian influenced, it can be written with an Arabic script that looks kind of like this. Well, this would be the Balti alphabet. And of course, since I'm going to have all this data to analyze, I'm going to need a database. And that's why I'm glad that you're here. So what's our favorite database? It's Postgres. Thank you. What's an easy way to get a Postgres? There's lots of easy ways to get Postgres. What we'll do is just spin up an EC2 instance here. And these are all commands. The slides are online. There's a blog post. You can follow along later if you want. Try this out for yourself. I'm pulling Postgres here. You can get it from the distribution repositories, but I'm actually going to pull it from the postgres.org official repositories. I'm pulling 15 for this example because I wrote this originally a few years ago, but it's a bit older, but it'll be fine. Then we're going to create a database for all of my research. Now, I expect my data to get pretty big, and luckily you guys are such smart people. You told me about this great thing, partitioning, that we can do. Now, I know the alphabet, so I can kind of split it up into about 4 sections by the letters. We'll set these partitions up. I like to measure my table sizes in gigabytes rather than terabytes. I think that's kind of a nice rule of thumb. So partitioning is one option that you might consider in order to keep your object sizes to kind of a reasonable, maybe in that gigabyte instead of the terabyte range. Now, it's time for me to get to work. Linguistics is pretty hard work. It's going to take, I'm going to do some work. I'm going to start accumulating a whole bunch of data here. We're going to populate it with some test data just for the purposes of this example. And one thing I do want to kind of mention, so these are kind of Arabic letters on the left, and then there's kind of a number. Because that is a right-to-left script, it looks a little bit funny on the bottom. So it'll like, the way it's rendered on the screen is that the letter is on the right-hand side of the number. It's actually the first character in the string, not the last, even though it looks a little bit weird, but I just want to kind of mention that. So just double checking that our data shows up. Now I've got my little dbeaver window because I'm an app developer and I'm very comfortable with this. So we've created our table, inserted the test data. We've queried. I'll zoom that in just a little bit for you, and you can see that we're able to query the data out. So after about a month of really hard work, my database starts to get a little bit slow because I've got so much data in there, right? I got these machine learning jobs running. I'm trying to do some ad hoc queries. Also, I have a growing concern that I don't want to lose my data, but it's a good thing you're here because you tipped me off that Postgres has a really great feature to help out with this, something called a hot standby. So what this is it's a complete copy of your database on sort of a second server. It's a whole separate copy of the data. It streams the changes across from the current database so that it's always up to date. And this can act, it gives us some degree of high availability because we can do failovers back and forth between our hot standbys. And at the same time, I can also run some of my queries over there. So I can open a read-only connection, offload some of my stuff. Now my queries are snappy again. We've killed two birds with one stone, and I am happy. The way that this is pretty easy to do if you want to set it up yourself. Again, I'm pulling a Ubuntu LTS release, pulling from the Postgres repos, same copy, and then you can just cut and paste the steps from the Ubuntu website right there if you want to do it. And we're up and running. Back in business, no time at all. So at first everything is looking good. We're partying, but it doesn't take long before I run into my first problem. I am just double checking my cross-references for the Arabic letter graph, which is one of the characters from that first screen. But when I run my query, no data appears. That's not good. So just to reiterate, you can pull this up, pull it up from my blog. You can get the latest version of Postgres, Postgres 17, have all the bug fixes applied. You get the latest opera. If you follow these steps, you will get exactly the same results. The data is going to just vanish. Now, this is not something that we usually expect from our databases. If you ever find yourself in a situation where you've potentially lost data or corrupted data, there's a couple things. This is one of the reasons, by the way, I think we're not going to be replaced by AI or robots or anything like that because of this judgment stuff that we bring to the table. Like, we know what to do when we're in a situation of something like potential data loss. There's a couple of things to keep in mind. I'm just going to quickly throw a few thoughts up on the screen. The first thing that I recommend anytime you're dealing with potential data loss would be an emotional support animal. Okay, more seriously, I do have kind of a couple of thoughts, and I'm not really going to dwell here. This was kind of geared around a different situation, but I do kind of like to mention a few of these things. So things like just have the foresight to say, don't make the problem worse, right? So if you have development teams that are working to say, hey, let's everybody pause, don't make any changes to the environments till we sort things out. There are a couple other things like the two-person rule means before you run any commands on your system, have somebody look over your shoulder or do a screen share. If you have another person that you work with who's not in the same physical location as you, just have them watch and have somebody double check the command looks right to them. Renaming, moving things instead of deleting things. There's kind of some good general principles around dealing with corruption situations and data loss situations. But the fundamental question here, which we've finally come to, did Postgres lose my data? Especially the latest, greatest version of Postgres, no known bugs, no issues. What happened? Now at this point I'm just going to like drop the answer, which is no, it didn't actually lose my data. What actually happened here, and it was really subtle in the slides, was that I mistakenly picked up two different versions of Ubuntu. They were both LTS releases, but the first one, when I set up my primary database, was Ubuntu release 20, and the second one was Ubuntu release 22. And what happened under the covers was that there was a change in collation, or a change in the sort order, which is what ended up leading to the data not appearing on the standby database. And the Postgres documentation, as always, is stellar. There's actually a section of the documentation that explicitly talks about this exact situation, where they mention that you can have a primary and a standby server with an inconsistency in the collation, maybe because the major operating system version is inconsistent. Don't do this. But we mistakenly did. And what I'm going to do now is I'm going to kind of hit the pause button, and then I'm going to turn the dial back in order to sort of explain the situation, give a little bit of a backstory. And I know some of you have seen this part before, because I'm going to go back to some of the content that we also talked about in Vancouver. I'm going to go about 7 years into the past and sort of walk through what's going on, how we sort of noticed it, and then what's also evolved and happened with Postgres over the last 6 or 7 years. So in order to dive into what's going on here, there's sort of two things that you need to know as backstory. All right? The first thing is this, that Postgres is, I think this is unique to Postgres too. I don't think, like Oracle, SQL Server, MySQL DB2, I don't think any other major relational databases do it quite like this. But Postgres, it uses external libraries for the string comparison and for the string handling code. Historically, it was originally the operating system provided C libraries, so like this here. And then sometime later, Postgres also added support for something called ICU, which is a library that you can get from unicode.org. A fantastic library. But in both cases, this is something that's external to Postgres. It's something that is installed and managed separately from the database. Okay, so you have this situation where, like what you saw before here, like that library can change outside of Postgres, and so the sort order can change. The second piece of the backstory is that about 6 years ago, people kind of working around Postgres started noticing, with a much higher frequency than had ever been seen before, all of these reports coming in about things that you don't really want to see when you're in the database world. Things like queries that give incorrect results, or duplicate primary keys, or mysterious crashes. And at the end of the day, what all of this ended up coming down to was changes in the sort order. So why would a change in sort order cause all of these things? Just sort of a simple way to think about it is like when you have an index. What is an index? An index is, it's taken all the values in the table, it sorts them, and then it writes them in order. And that's kind of one of the fundamental ideas of an index, is that they're in sorted order. So if you change the sort order, but your index is all on the disk, now the index is in the wrong order, right? And if that's unexpected, you didn't expect that, that can lead to all of these types of things. So I think that the easiest way for me to sort of walk through some of the history and the evolution over the past 7 years is just to tell you 23 things that I got completely and utterly wrong throughout this whole process over the last 7 years. And the first thing is the first thing is very simply the idea that putting words in order is simple. All right? If you could be forgiven for thinking this if, like me, English is your first language, you grew up in the States. It is actually fairly simple when you're working in English. We have 26 letters. If you're dealing with ASCII, you really can pretty much do a mem compare, and you can get the letters in the right order. Okay, I'm going to do another quiz, because I like quizzes. These are fun. Are you ready for this? On the screen in front of you, I have another, no, not another, this is the first one. I have a SQL query. What is the output of this? It's fairly simple. It's just 5 rows, order by word. What is the output of this SQL query? Look carefully. If you think the output of the SQL query is the column on the left, raise your hand. Column on the left. Any takers? No. Okay, center column. 1 vote for the center. Does that mean all the rest of you are voting for the right column? Right column? No, there's a couple non-voters in here. I don't know about this. Let's find out. All right, I apologize. I'm sorry to tell you that, in fact, the left column is what you're going to see if you run that query in Postgres. Unless your collation is traditional Spanish, in which case you would see the center column. But what about that right column? Is that? Yes, that also is valid. In fact, all of these, I kind of tipped you off with the first quiz where all the answers were correct. All of these are, in fact, the correct answer. A quick note, I even put the syntax at the top. So you have a default collation, but if you can still even get these results by it being explicit, and this is the syntax that you would use. You could put that collate and then that string, and you would get this order on your Postgres database. The same on the right. This syntax is a little bit different in the middle. And the reason for that is Postgres, it has like named collations, all right? And then there's a lot of flexibility for creating. I can make something called Jeremy's collation, and it can have a whole bunch of custom rules that I invented. In my test system, it didn't have any collation out of the box that did traditional Spanish for me, so I had to create a collation, Jeremy's collation. That's the syntax that I would use to create it. And then I would, in my SQL query, I would say order by word, and then I'd say collate Jeremy's collation. And that's why the syntax looks different on the middle column. Long story short, linguistic collation is a lot more complicated than you might think at first. It's certainly not as simple as I used to think it was. There's a whole bunch of things. One interesting thing about this list back here is if you look at the bottom two entries, like you might not think at first that CH could ever come after CO. Like, what's up with that? But in traditional Spanish, CH, those two characters together, are a letter. And that's called a contraction, which is the first example up here. So for purposes of sorting, you treat those two things as a unit. And then there's a whole bunch of other situations. Expansions, backwards accents are two kind of like big and easy examples. There's a bunch of other smaller ones too. Long story short, I like to think of this like your high school English class, where your teacher was trying to get you to learn all of these crazy rules about language. That's kind of what we're dealing with. When you talk about putting words in order, what we're really talking about is all these things that we come up with as people for how we deal with language. So it really does get complicated fast, especially when you're dealing with all kinds of different languages in different countries around the world. But at least we can be sure that the way we put words in order doesn't change. So if there's a change in the sort order, that must have been a mistake by a maintainer of that library, surely. Well, this turns out to be wrong too. Correct ordering does change. Now there are like bug fixes and there's fixing mistakes, but that's not the only thing. There are also some interesting legitimate things. One example that comes to mind, I'm not a native French speaker, but my understanding is that if you pull half a dozen or a dozen French dictionaries off the shelf from various with different ages, you'll get conflicting opinions about whether you should do something called backwards accent sorting or backwards secondary accent sorting. It's, so there's a consensus today on like the right way to do that in the academic world, but that's evolved over time. And the way I think that a good way to think about this in the context of language and sorting is that the way that we compare strings, it's more like time zones than it is like mathematics, all right? Like time zones don't change often, but they can change. It is something that can change. And the way you put words in order, that's not something that's going to change a lot. It's not something that's going to change often, but changes can happen. So they can happen, but surely they're rare. And there's a grain of truth to this, all right? So the big change that got everybody's attention back in 2018 was rare. That was rare. And if you don't know about this, you should. glibc version 2, it's been a while now, so the word's kind of gotten out, but then again, it depends kind of like if you were in these circles and you heard about it. There was glibc 2.28 was released, and in 2.28, they were bringing their collation code kind of up to date with Unicode 9. In the process of doing that, one of the things that got impacted was the way that they deal with white space. So you could have a letter and then a dash and then a letter, and the way that that was sorted could change when you went up to glibc 2.28. And the net effect of that is that even strings that are pure ASCII, like just ASCII, this stuff could change sort order. And this made this a really very impactful thing. What that meant was that if you had a 10 terabyte database, which you really didn't want to like PG dump and PG load, and you just tried to detach those disks from your Red Hat 7 server and plug them into your Red Hat 8 server and spin Postgres back up, the moment you did that on Red Hat 8, a whole bunch of your indexes were corrupt instantly, right? Because the sort order changed. Even you had a whole bunch of stuff, the sort order changes, corruption. missing records, all of those things that we talked about at the beginning.
Slight correction.
Slight correction.
They were instantly producing wrong results. They were only corrupt if you allowed an insert or update.
Instantly producing wrong results. Fair. So this is the big change. But something that I was curious about was, are there smaller changes happening that we're not noticing? So we came up with this idea of trying to do a test that would tease out the smaller changes. I think it was Joe who came up with the name, calling it the torture test, which I love, so we're running with that. And the basic idea behind this test was to take 10 years worth of historical versions of both Red Hat and Ubuntu, every single assigned code point in Unicode, and about 91 different string patterns. These aren't completely arbitrary. Some of these were baked in with a little bit of knowledge of like things that we knew had happened. And when you put all of that together, you end up with a list of about 26 million strings. And this isn't perfect. It's not guaranteed to catch every sort order change, but it ends up being pretty good. It ends up catching a lot of sort order changes that can happen. So we just take that list, 26 million strings, sort it on each of those versions, and then just diff. Do a comparison, look for changes. Very easy test, right? What we found was a little bit surprising. We discovered that every single Red Hat major release and every single Ubuntu release in the last 10 years, except for 14.04, has sort order changes. So while the big changes might be uncommon, small changes are happening all the time. One also thing that I like to mention, all the code for this, generating that list of strings, is up on GitHub. Joe's sitting here and he's giving a talk tomorrow, and I have a copy of a slide from his talk. He came up with this really clever way that you can sort that list, generate a checksum. You could drop this in a CI/CD pipeline in your own environment, and this could be a way that you could test for and trigger and flag if there was ever a sort change with your software or in your environment. Kind of a cool trick that you can do. So changes are happening more than you think. But changes only happen on purpose. They wouldn't happen by accident, would they? Well, my favorite counterexample to that is this glibc commit from the year 2014, which had nothing to do with sort order. You can read through the commit message, read through the code. They were refactoring a cache for performance reasons, but it had the side effect of, if I remember right, it was like, I think it was like Japanese kata characters combined with like some kind of ideograph. It was combining characters from two different scripts, but it was something that absolutely does happen in Eastern languages. And what happened was it didn't have a defined sort order, so it wasn't right or wrong whether you put it this way or this way, but it changed. So again, like, it's not a bug, it's not an error, and it wasn't even intentional, but the sort order changed with this commit to glibc. But fortunately, indexes, as we know, are the only thing corrupted, so all you have to do is rebuild the indexes and you're safe, right? Wrong. In fact, we already gave an example, if you were watching up at the beginning, where we walked through, there were no indexes, as somebody pointed out. No primary key, only partitions, and we still managed to corrupt the database. Well, corrupt. You're right, Joe, it's not corrupted. It was just returning wrong results. But if I would have failed over, it could have quickly become corrupted. So it is not just indexes. There's a number of other things as well. Constraints. We've seen some demos with foreign data wrappers. I don't mention hash joins and hashing up here, but that can also be impacted as well. In short, there's a whole bunch of places. Doing string comparisons is just fundamental. Like, it's all over the place in the code, all over the place in the logic. And there's all kinds of places where data might be persisted down and rely on an assumption about a string comparison that happened in the process of being persisted. But luckily, we can just, okay, so it's not just indexes, maybe a couple other objects, but all we have to do is rebuild the objects. So it's inconvenient, but there's a fix, right? Well, if you were paying attention, we already kind of saw the counterexample to this too. Hot standbys. What about hot standbys? If you have a hot standby, these have, by definition, have to be the same. So if you have a hot standby and you have the wrong operating system there, what you're doing there is just hoping and praying that you didn't fail over, and as quickly as possible shutting that standby down and rebuilding it with the correct operating system or the correct libraries. Now this is a fun one. My database doesn't have any characters from that uncommon language with the sort order change, because the changes are happening all the time, but often maybe it's just Tibetan characters. Maybe it's, some small language from Asia that's not widely used. So this is a really common line of thinking that like, well, I'm sure that that character is not in my database, so I can just ignore it. It's fine. I don't really need to worry about it. In fact, I could update my collation libraries and just ignore the warnings. And this one, my response is that two things. First of all, right here, right now in Seattle, we probably have people from every corner of the planet. I know this morning I started out my day down in the exhibition hall talking to a few people who are here from Europe. It's 2 taps on your phone to get the character, to get the keyboard, to be able to type your name in any script that you want. And this isn't even to get into emojis, which are happening all the time. And the thing that you have to think about is that how does data get into your database, right? If at any point in the flow there's a form where somebody can type stuff in, and this is where like I have seen enough weird things that it has completely dissuaded me from ever making assumptions. I've seen a system where like the login names that people were doing had like random strings of emojis as part of their login name. Who knows why? Just for fun. But there's unexpected characters. The thing about Unicode, sort of the way that Unicode works and inherent to it, is it does everything it can to get out of the way and to make it easy for characters to kind of wind up wherever they want to go. But this leads into the next incorrect assumption, which is that your database understands all the characters that are in it. Because sort of, if I open my database and I look at a column and I see character that's just completely unrecognized, an unassigned code point, it's just like a square box, that surely must be a mistake or a corruption or something like that, right? Wrong. Why? The reason why is that this is a completely realistic timeline that happens every single year. It turns out that companies like Apple and Samsung and Facebook and they're not called Twitter anymore, but X, I guess. They're very, very good about staying up to date with Unicode updates. So it's less than a year from when a brand new version of Unicode is released with characters. Usually, emojis are the big thing driving this, but there's going to be some characters that have never been seen before. They're brand new, just invented. Within less than a year, the keyboards on people's cell phones support those characters. So those can be tapped into a field. And if your database rejects any unrecognized characters, what's going to happen is anybody with the latest iPhone is going to get error messages if they try to use that new character on their keyboard. So the choice you have to make there, like if you were to do that, you would just be giving users errors. So my feeling on this is that probably what you want to do is accept characters and store those characters, and you process them using whatever rules you have, and you just kind of have to understand that you're going to have to manage that. With a new character, there will be sort of new sorting rules that come in for how to deal with it, but you can sort it using, there's an existing rule that's there. And then in order to get the new rules, you're going to have to be careful with that because we're going to introduce all the things that we're talking about here. So on those updates, one good thing about Postgres is that it will try to detect if the version of the library changed, and it'll display a warning message, right? It'll display a warning message. Well, if you go through the steps that we had, in fact, no warning message was ever displayed. Now, this was dbeaver version 23. It's possible, again, I originally did this demo a few years ago. They may have updated it. What happened in dbeaver 23 under the covers was that the warning message came through at connection time. So when connecting to the database, a warning message was sent. And I have a suspicion dbeaver probably stored it somewhere in a log file or something, but it was never displayed to the end user. Now, it was put into the server log, and I'm sure that like all of you immediately see the problem here, right? Right? Did you see it? Probably not, because this is kind of the issue with the server log, is like how many of you go read your server log every day looking for that? Most people are going to go looking for this message after they've noticed a problem, like missing data or wrong query results. And that's kind of not really when you want to find out about this. Ideally, you want to find out about it the moment you start up the database or something like that so you can take care of it. But then that gets into an even more of an underlying question. Postgres would reliably detect this, right? As long as you're on a common operating system, yes. So if you're on most of the Linuxes, FreeBSD and Windows, yes, but not everywhere. Because Postgres, again, this is an external library, and Postgres needs a way to figure out what is the version of the external library. And in the case of something like, say, glibc, like glibc doesn't provide a function you can use to introspect the version. So you're kind of essentially, you're back to whatever the operating system provides. ICU does give some stuff for trying to detect, to introspect the version out of it. All right, this next one is a fun one. I think you came just because you knew it was in here. I will say that I was in the room early on when people were throwing this idea around. They said, what if we just took all of that collation logic from like the operating system? It's not quite, it might as well be the kernel. It's like libc. Like we'll extract all of that out, put it in its own library, and then you just install that on Red Hat 8. And I definitely said, no, that would never work. That's crazy impossible. You can't do that. And I still maintain to this day that there are only probably about 5 people in the world who could pull off something like this, and one of them is in the room. So Joe's been involved in Postgres for a long time. So this is pretty darn cool, and it's really worth knowing about. So what Joe put together, and this is again up on GitHub, you can pull it down, is a set of packages that does exactly that. And it's actually able to extract the collation code from glibc, bundle it into a separate package that you can then go install on a different major version of Linux, of whatever distribution or operating system you're using. Now, this is still not like an ideal solution. Like, if you need this, you know you need it, and it's there for you to use it. But if you have the option of taking other solutions are better. Use ICU instead. That's a better solution, right? This was an old one where you originally started talking to this. Joe, what time is your talk tomorrow? He doesn't remember, but he has a talk tomorrow. 10:40 or 11. So if you want to learn more, and then I know you're going to be talking about it kind of a different angle on the same topic, that's tomorrow. And this is some really fantastic, amazing work that Joe has done. All right, my next one, number 12, this is the one that all of us, myself included, so badly wanted to believe for many years, and that is that ICU is going to solve everything. We really, really wanted this to be true. And don't get me wrong, because ICU is a far better choice than using the operating system when it comes to collation. Something that I like to say is that the C libraries are written by like kernel and operating system nerds. ICU is written by language geeks. Right, like these are people like if people that get involved in Unicode are usually people that like are really interested in language and sort of all the kind of human aspects of computing. So ICU is a fantastic library. It is better, but it doesn't solve everything. If I run the same exact collation torture test on ICU, you're going to find, unsurprisingly, exactly the same thing, which is that every release of ICU also has sort order changes. Right, so you still have the constant changes. Now what's better is you're in a much better position in that you can take an old version of ICU, compile it, and install it on a new operating system. That's a lot easier than trying to do the same thing. We did it with glibc, but this is a much cleaner, easier way to do that. But it doesn't solve everything. You still have the changes. You still need to deal with that. But at least it's never had a huge change like glibc, right? Wrong. I put a big arrow. In case you missed it, up at the top, in between ICU 52 and 55, they had a similar massive, gigantic change. So quickly summarizing that torture test, both glibc and ICU have regular changes to sort order, as we would expect. They've both had at least one release with a huge number of changes, and you can jump out on the internet to GitHub, and you can find a couple of code snippets to help you if you want to dig into this stuff a bit more. Number 14. Now, I've called out Devram and Christoph here. You probably don't know who those people are. Devram's actually here. I saw him at lunch today. Devram and Christoph, Devram is one of the people who probably is most involved in building the RPM packages that I would suspect over half the world uses to run Postgres. Christoph is very involved in building the Debian packages that half the world uses to run Postgres. So since they, of course, are building Postgres and packaging, surely they could just build all the old versions of ICU for everybody? the computer, my loaner computer, has a weird, doesn't have very good emojis on it, which is why it did that. It's supposed to be clinking beer glasses. It's unclear that we actually want to be putting old versions of ICU in the Postgres repos. It's an interesting topic. I do like to sort of say the Postgres community is very welcoming and open and love people to get involved. And if you have opinions about this, jump on the mailing list and get involved. So next, sort order doesn't change. So far, we've been talking about major operating system upgrades, like Red Hat 7 to Red Hat 8. But what about those like bug fix releases, those patch releases? Those should be pretty stable, right? Generally, they are. Like, for the most part, you know, glibc is pretty good. The way glibc works is the 2.26, that's kind of like a major version, and then there's patch versions that go afterwards, and generally sort order doesn't change in those patch releases, except when it does, or when it did. But it wouldn't change if there's no version change, surely. So ICU versions the collations, and like, I don't know how this happened. This is just, you know, chalk it up to the mysteries of technology, but somehow things just happen. ICU version 73 had a bug fix. They didn't bump their collation versions, and yet the collation changed with no version number change at all. So this is fun because, like, you wouldn't have even gotten, there's no way Postgres could ever warn you about anything because there's no indication. Like, it would think it's the same version of the library, right? And yet the sort order can change. And that leads to number 17, which is that Postgres does not have any built-in provider. And this goes back to my very first slide. I said Postgres only has two options. You can do the operating system or you can do ICU. Now, when I said that, that was what I originally thought, although I kind of knew about this, but not completely. Actually, there was kind of this third option that's been there all along. And that third option is something, it's very narrow, but it exists, and it's called the C locale, or the POSIX locale. And this is, now this is not, what this is going to do is just, it's going to do your string comparisons just like binary, just like bits, all right? Or code point in the case of Unicode. So it's not sorting things like in a sensible, now if you're speaking English, it's actually, other than putting upper and lower apart from each other, it's actually going to sort things correctly. If you're talking about ASCII. But outside of that, you're going to see it's computer order, not human order. But it's there. But that leads into the next thing, which is number 18, that C is the same thing as C.UTF-8. Now, these look very similar, but in fact, they're very different. The second one, that's the same pattern that you use anytime you're asking for a collation from the operating system. So you would do en-us.utf8. Or you could do fr-fr, French from France.utf8. And that's the clue. The one on the right, the C.UTF8, is both of these are POSIX collation. But if you do that syntax, what you're actually going to get is it's going to call out to the operating system for its collation. But the one on the left, that's the interesting one, just C by itself. That, for a very long time, has been something that was just completely implemented and built into Postgres internally. It's right there. It's not widely used, and there's a reason for that I'll get to a little bit later. But it's actually been there all along. But these aren't quite the same. Now, C.UTF-8 is interesting. So that's calling out to the operating system, but it's doing code point collation, binary. So you can't really get that wrong, right? That couldn't change, could it? Again, I have no idea how the glibc people managed to pull this off. Actually, I do a little bit because there's some interesting history around it. There were some workarounds being done for many years, and in about 2015, the glibc folks were like, we need to clean this up, do it right. They started a project, took them 6 years. The commit landed in 2021. But the net result, somehow, you can walk through 4 different versions of Debian, like we have in this email from the Postgres mailing list, and you can actually, using the C locale, you can get changes in the sort order between certain characters. It's kind of mind-boggling and amazing, but it actually did happen. So amending our table just a little bit, the C collation is stable and safe. It's never changed. It's built completely inside of Postgres. But the C.UTF-8 collation, it should be stable. Like, I wouldn't expect, because it's not like linguistic sorting where you have updates happening all the time. Shouldn't change again, knock on wood, cross our fingers, but we have had some history there, and history has shown that it did change. Now here's a fun one. So far this entire time we've been talking about sort order, because that is what the word collation kind of means. But in the Postgres world, the collation provider actually does double duty with something else that you might not catch at first. The collation provider isn't just doing the sort order, it's also doing a second really important job called character semantics. Character semantics is, if I throw a character at you, tell me what it is. Is it number, letter, punctuation, uppercase, lowercase, like classifying, all those things. And the collator also is responsible for that. And the illustration is, if you look at the initcap function, right? This comes back to the problem with that built-in C locale. That built-in C locale only understands ASCII. So the moment it sees this lowercase e with an accent, it's like, I don't know what that is, must be a space. And it basically treats it like a space. So it's capitalizing the L and the E, right? Which is incorrect, but it's the limitation of that built-in C provider, the C collation provider in Postgres. And it ends up being a pretty major usability issue, and probably one of the biggest things that would prevent you from wanting to use it. You see down here, if we're doing POSIX collation, but we're calling out to the operating system, it's done correctly. So glibc does it right. glibc recognizes the characters. Number 21, the character semantics surely wouldn't change, would they? Well, we're also concerned about that. We've had some discussion here. This is another thing that we're worried about from the operating system. And we're getting close to winding it up here. Number 22, this one got a ton of discussion, I think, over time. All of this time, one of the things that I've been talking about is this like binary collation, because if you're doing this binary like code point collation, theoretically you could avoid a lot of these concerns about sort order changes. But like the big problem is users would never stand for this, right? Like obviously people need to see their list of French names in order, like not just random unusable order. It has to be something that makes sense. If you have users anywhere using any language other than English or any characters other than ASCII, it's just not a usable experience. I wanted to dig into this a bit more, so I decided to spend a little bit of time surveying all of the major relational databases and trying to get some background. The first thing that I discovered in doing that was that every single major relational database has weird quirks around collation and encoding. It is bizarre and hilarious. I think part of that comes down to that like encoding and collation decisions tend to be almost like one-way doors in database land because it's persistent. So like early decisions are very hard to get away from in every database. So what you wind up with is just like, you get this stuff that follows you on. So every single database vendor, nobody got it perfect on the first try. So it's different for everybody, but everybody has weird quirks. Whether it's MySQL's like weird UTF 3-byte thing, or Oracle. Oracle's my favorite because Oracle, if you're in America, it's all binary by default. But if you're in Europe or the Middle East or Quebec or this like random, you have to go to the appendix of one of their docs for a list of countries because it's like random. In certain countries you get linguistic in air quotes by default. What that actually means in Oracle is that order by is going to be in French, but greater than and less than are going to be in English or are going to be binary. So think about that for a moment. Give me all my names, order by last name. There, come down. Now, where last name is greater than Schneider, the greater than, like, and I have a demo on my blog, like it'll like pull out the middle three. If you get like the right list. It's hilarious to me that they have like different operators in exactly the same SQL statement using linguistic versus binary. But again, like old decisions that are hard to get away from. There's ways to change, all of these are configurable. There are always ways to kind of configure around it, but often the defaults are geared around a lot of history. But the main takeaway here is that actually, it's not uncommon at all to have the database default run with binary sorting, and Oracle's a great example of that. And what Oracle does, which I think isn't bad at all, is that they say, for a lot of times your database default, half of that is just stuff like equality checks on, say, primary keys that happen to be a string instead of a number. There's a lot of things where just speed of computing matters and it doesn't need that. And they say just default the database to binary, we have all the linguistic stuff that you need. You just do it. You can set it at a table level or at a query level when you need it. So you use the linguistic sorting when you need it, but you can run the database defaulted binary. And I think there's a very strong case for taking that same approach with Postgres. I would recommend this. With Postgres, there's a second reason to do this, which I think is very compelling. If you want to ask the question in Postgres, tell me all the places in Postgres in my database where a string comparison could possibly happen. That is a very hard question to answer. On the other hand, Postgres has fantastic dependency tracking. There's a table, like it's actually tracked right in the schema. If you have a collation and you want to say, tell me all the places in the database that use a non-default collation, that's like a one-liner SQL query. It's very straightforward. So if your database default is set to binary and you use all the linguistic stuff, at a, say a table level or something like that, it's very easy to quickly find out a list of all the places in your database that have linguistic collation. And then if you need to update your ICU version, you need to get rid of ICU version 49 or whatever it is, I can easily get a list of exactly what objects are using ICU and figure out a plan. And it's very straightforward and easy to do. So that's why I advocate for that. And last but not least, number 23, Postgres is not likely, if you've been around Postgres, one thing that you know is that the development community behind Postgres doesn't tend to do like these high-risk, big bang, massive changes. For the most part, like logical replication is a great example of this. Things tend to be incremental over time, right? And I don't really expect like Postgres to just solve this problem overnight. And I will say here, Jeff is sitting right there. He did a lot of the work. Blew my mind that Postgres 17 was released just a few months ago. And Postgres 17, this isn't necessarily a headline thing because it's kind of systems level. It's not something developers would necessarily notice. But this is amazing. Postgres 17 actually includes, they added a built-in collator that does the C collation, but it fixes all of the usability issues that we were talking about with that old built-in C one. So it pulls down, there's actually some code in there that goes out to Unicode. We pulled down sort of the current Unicode version with the right character semantics for 2023, uppercase, lowercase, all the recognized characters, converted that into C code, checked that directly into the Postgres source tree, and Postgres has now a sort of like a very usable, very good quality built-in byte order, so it's not linguistic. It's still only sort of binary byte order, but it's built in. It's guaranteed not to change. It's safe. If you're on Postgres 17, my opinion is give this thing a spin as your database default, your system default. All right, so I've got about like 2 minutes. And with my last 2 minutes, I am just going to take about 5 seconds, well, no, more like 1 minute, on a couple of just advanced collation topics. Number one, just very briefly, I touched on this earlier, but like other things in Postgres, there is kind of multiple levels at which collation can happen. And I've walked through the 6 levels here. First, it picks it up from the operating system environment. My recommendation is use the bottom 3, not the top 3. So the top 3, in my opinion, that's where I would use. If you're on Postgres 17, use the new built-in one. If you're on an older version, I still think it's a good idea to use POSIX just to reduce the amount of risk. And also to kind of get in the habit and set the expectation for application developers that they need to specify a collation when they need it. There are conflict resolution rules, and I've noted down here, you can pull the slides down later if you want to know where to look in the Postgres docs to learn more. A couple advanced tricks. ICU is the place you go for collation. Just go to ICU. ICU is amazing. ICU has a lot of functionality that you just can't even get from the operating system, from the C libraries. And it's really, really cool. So things like case insensitivity, things like ignoring accents, numeric value comparisons, some really cool things. The Postgres docs, again, are stellar and kind of walk through the basic usage. And then you can even do this thing with ICU where you can create your own collations that pull in some of the advanced features of ICU. The most extreme example I've seen of this, which I think is like super fun, is using ICU and like explicitly defining each comparison to actually build a sort order that exactly mimics a 30-year-old IBM code page, so that somebody doing a migration could validate post-migration, run their queries, get the data in exactly the same order as they had on their mainframe their mainframe. And like we worked with an IBM person to map all the code points over according to the IBM code page mappings, and we did that with ICU custom rules. That's the crazy stuff you can do with ICU. Lastly, on the ICU stuff, my favorite place to go if you want to learn more is Peter Eisenstraut's blog. He's written a bunch of blog posts about this. So lastly, wrapping it up, just my key takeaways here. I'm just going to reiterate sort of two things I said earlier. Number one, this is kind of me, but I think everybody should assume there are unexpected characters in your data. I've seen weird stuff, and that's kind of something that I feel like it's an easy mistake to make, but you're going to be surprised. Better safe than sorry. Number two, if you need to upgrade your operating system and you want to be 100% safe, these are your options. All right? PG dump, PG load, always safe. That's a logical dump. That's always fine. Logical replication, you do need to be careful with logical because logical replication always involves like a seed or like, an initial build out. If you use like create subscription, create publication, and if you let Postgres do its thing, it's just copying data over the network, that's totally safe. Don't like physically copy your files because then you're back to the original problem of the indexes. You can always use the old version of glibc or ICU. That is always safe. And then finally, if you're on Postgres 17, use the new built-in collator. I'm a huge fan. Thirdly, again, like on that note, I recommend moving toward a database default of C collation. Even on older versions, like I said, I think it's worthwhile to get your developers in the habit of defining it when they need it. And then lastly, look at ICU. And then, of course, lastly, I had to put this in there. Don't underpay your administrators, your DBAs. They're very important. I end every talk with the happiness hints. These are something you can find online, kind of a set of best practices for Postgres. And here at PASS, we are collecting feedback. So I would like to request, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A lot of people here. So if please do me a favor, hit the QR code. I hope it's working now. If the QR code doesn't work, go to the URL, put in an evaluation. I will leave that up on the screen and put my contact information up here. But the PASS Data Summit does want your feedback. So if you learned something new today, or if you thought there was some interesting topics here, please give the feedback to PASS. Thank you very much. That's it. And I did it. 100 slides, 50 minutes. I think I might have gone 2 minutes.